Hey, folks, and welcome back. Hope you all had a wonderful spring break. Today, we're going to be talking about our new unit number 8, which is on work, power, and energy. So, for the first half of the unit, we're going to focus on work and power, and that's what we're going to be introducing today. So, we have a guiding question, which is for this one, which is, are the Avengers doing work on Thor's hammer? And I'm not going to play the video here because it doesn't play very well through a video. But if you want to go ahead and pause this video, go back to the the Canvas assignment, and then click on the link to the slides. You can get access to the video. So go ahead and watch the video, pause this one, go back and watch that video, and then meet me back here. Okay, so hopefully you've watched the video, and the only Avenger that is able to do work on Thor's hammer is Captain America, because he is the only one who's actually able to move the hammer. So, what is what is work in science? Well, work is done whenever a force acts on an object in the direction that the object is moving. So none of the Avengers were able to do work on the hammer because they weren't able to lift the hammer, except for, of course, Thor himself. Work is only done when an object moves. Okay, so objects that don't move have no work done on them. Now, that doesn't mean that you're not necessarily applying a force to them, right? If I go up to a wall and I push on that wall, I'm certainly putting a force on the wall. However, I'm not doing any work because I'm not actually causing it to move, right? So in our little video clip up here, we've got our raccoon friend who is pushing a grocery cart, right? Work is being done on the grocery cart. The raccoon is using a force to move the grocery cart, and so therefore work is being done. So again, which Avenger did actually work on Thor's hammer? Thor himself is the only one who actually got the hammer to move, and so therefore he's the only one who did work. So how is work calculated? Well, we just kind of talked about the fact that work is done whenever a force is used to move an object. And so because work only occurs when a force causes an object to move, we calculate it by multiplying the force used to move the object. So however much force we actually use to get it to move, and we multiply that by how far the object actually moved. Okay, so the unit for work is the joule, Joule. Okay, it's named for the scientist who kind of figured this out. And work is equal to force times distance. This is our equation down here that you need to be able to use. Okay, so pretty straightforward. Work is just equal to the force that you used multiplied by the distance. So if you have more force, right, then you're going to have more work. If you have more distance, then you're going to have more work, or you will have done more work. Okay, what is power? All right, so we talked about work. What is power? Well, work can be done slowly or it can be done quickly, and power is how quickly was the work done. All right, so if we increase the amount of work, right, if we do more work, then we will increase the amount of power we do. Conversely, if we do something faster, if we decrease the amount of time it takes to do something, right, then we are going to increase the amount of power. So doing something very quickly means that you're using a lot of power. Doing something slowly means that you are using less power. So we've got two different weightlifters here. We've got the big guy on the left. He's got a lot of power for two reasons. Number one, he is lifting a lot, right? So he's doing a lot of work. He's got a lot of force that he's having to use. And he's lifting it very quickly, right? So he's developing a lot of power. He's doing a lot of work in a very short amount of time. Our little scrawny guy on the right, He's a little slower. He takes a little bit more time to lift his weights, and also he's not lifting as much weight, so he's not using as much force, and so therefore he doesn't have as much power. All right. So power is just a measure of how quickly work is done. It's a rate. Okay. And so because it's a measure of how quickly work is being done, power is equal to work divided by time. It's just how much work did you do divided by how long you did it. So that's how we can see, like, if you do something more quickly, right, you'll end up with more power. If you do something slower and time is bigger, then we'll end up with less power. So make sure that you write that down. Okay, so that is the end of the notes for today. Pretty straightforward introduction. Make sure that you go in now and you write your summary of the notes, 2 to 3 complete sentences, and then you need to answer the questions at the bottom, right? So we got kind of a mix of questions here. We've got some conceptual questions where we're just kind of thinking about the concepts of work and power and saying, okay, is there more work, less work? Is work actually being done? Is there more or less power? And then you have some calculations. For your calculations, These are very straightforward ones. I'm just asking you to calculate either work or power. Okay. So remember, work is equal to force times distance. Use that equation. And then power is equal to work divided by time. And one thing I forgot to mention is that the unit for power is the watt, W-A-T-T. And you may have seen that before on light bulbs, right? Maybe you have like a 60-watt light bulb, or if you have or maybe a 60-watt equivalent white light bulb if you've got LED light bulbs, right? And that's just telling you how much power that light bulb is using, right? It's how much work is being done by the electricity that's flowing through it. So, anyways, if you need help or have questions, as always, feel free to reach out and ask. Hope that you have a great day, and I hope to see you soon.